Welcome back. In the last video, we introduced you to a situation where a company uses naive Bayes to determine whether an individual should be hired based off the text from their resume. This system was only trained on 2 previous resumes. And we asked what would happen if we gave the system a resume like Sandra Ramirez, CS major, 5.0 GPA.
The problem in this scenario is that even though Sandra Ramirez has a higher GPA than James Wood and Sandra Smith, she would not be hired. All of the words, aside from Sandra, are considered neutral by our naive Bayes system. The name Sandra was only seen on a resume that was labeled as no hire. Therefore, our AI would reject Sandra Ramirez's resume simply because she's named Sandra.
This introduces us to the problem of biased data in AI systems. Since we trained our AI on data that associated female names like Sandra with resumes that shouldn't be hired, the AI reflects this pattern in the data and is therefore less likely to hire people who are named Sandra. One way we can improve this situation is by paying attention to the biases our AI system has learned. To counteract these biases, we can add more varied data to the system's training data set.
In the first video, we told you that machine learning systems adjust their functions when they receive new data. So, in our hypothetical situation, we could train our system with more resumes and hope that our system would learn that GPAs should be more important in determining whether a person should be hired or not. We could also modify the data that we give the AI. For example, we could go into the data and remove the names from the resumes so that the system can't associate names with hireability. This could make it so that people wouldn't gain advantages or disadvantages as a result of their names, and the AI would be forced to rely on other patterns in the data.
However, while these steps could definitely make our AI a little bit more fair, there's no guarantee that it won't produce biased results. In fact, even if we added more resumes and removed things like names, there could be hidden biases in the data. For example, one study has found that female applicants for CS jobs are more likely to use words like volunteer and assistant. If the industry's tendency to hire fewer females is reflected in the training data, the AI could learn that these feminine words should be associated with non-hires and indirectly penalize applicants for their gender. And this is just the tip of the iceberg when it comes to bias in AI.
Since the bias largely stems from the data itself, all AI systems, from the simple ones like naive Bayes to even more complicated ones, are susceptible to this issue of biased data. In fact, there are several real-life cases of bias in AI having detrimental consequences. Take the use of AI in facial recognition systems, for example. These systems are typically trained with the faces of the engineers that worked on them. Since the tech industry has historically been demographically skewed towards white men, this means the systems are trained with predominantly white male faces. The effects of this training are apparent in the performance of these systems. Studies have shown that these systems are more error-prone when evaluating female or darker-skinned faces than when evaluating white male faces.
For instance, Amazon has created a facial recognition system known as Rekognition and has been marketing their system to police forces and federal departments as a way to help identify and locate criminals. However, the ACLU ran their software through photos of members of Congress and found that the software misidentified 28 members. Many of the errors disproportionately happened to members who were women or people of color. This can have grave consequences if we end up relying on this software for criminal justice.
Amazon's facial recognition software is far from being the only one that has these flaws. Facial recognition software from tech giants like Microsoft and IBM have had equally concerning errors. Researchers have found that when given the faces of darker-skinned women, Microsoft's facial recognition software results in errors roughly 21% of the time, and IBM's system 35% of the time. For light-skinned males, however, both softwares had an error rate of less than 1%. As with our hypothetical resume scenario, one possible solution for these real-life cases is to add more varied data in these training datasets. Adding more faces of women or people of color can make these systems more robust. These problems can also be mitigated by testing these systems on populations that are less represented in the initial training dataset.
Additionally, a broader, though albeit much harder, solution is to make the tech industry more diverse as a whole. If we have more women or people of color, or even more allies in these teams advocating for the software to work well for all demographics, we can hold the industry accountable for these errors before their software is even deployed. We can even shift AI use cases to counter systemic oppression rather than continue it. Now that you all know a little bit about AI, we want to emphasize that we don't want to dissuade you from using it. AI can be a powerful and effective tool, so long as we stay vigilant of its subtle yet consequential pitfalls. As AI systems become more prevalent in society, we hope that you can be part of the movement that works towards using it for good.